Lesson 4 asks the question, could we plant trees to solve the climate change or the climate crisis? Again, it's been something banded around in the media that actually maybe we just need to plant more trees. So the purpose of this lesson is to try and unearth the science and the fact in that question. Playing on the fact that maybe geographers being tree huggers and the idea of loving, enjoying nature. The beginning of the lesson, take all the students outside and go and stand round a tree and then use that circumstance to ask questions about what is it that that tree does, what are the natural processes, what value is it adding. And then you can kind of expose the idea that trees lock away carbon and think about the process of photosynthesis but also decomposition and introduce the idea of the carbon cycle. What you then want to do while you're outside is have a go at measuring the size of that tree. And that data we're then going to use in the lesson to estimate the amount of carbon locked away in that individual tree. So I've created a sort of simplified worksheet here that creates a relatively crude but kind of feasible and accurate for this discussion, where you have to estimate the tree height, and the best way to do that is to use Pythagoras' theorem, where you then have a 45-degree angle, you walk away from the tree, and then measuring the distance between you and the tree is then an accurate representation when adding the height that you're holding the clinometer at to estimate the height of the tree. So the height of the tree might be something like 15-20 metres. You then want to have a go measuring the circumference at 1.5 metres, so around chest height. And then using that, when you're back in the classroom, you can calculate the radius, the volume, and then from that, we can, knowing the type of tree, so for example, I've used pine trees that we've got on the school site. We've got the density of pine from this table here. We can then calculate the mass, and then the mass of wood, and then the biomass, and then ultimately, using proportions, we can have a look at how much carbon is actually locked away. And this is a really good activity to kind of enforce and emphasise the idea that maths is a really key skill in geography, and to get them to do some relatively basic but often quite challenging maths. The idea then is you've got a kind of a rough idea of that one tree, and then you can start to scale it up. So you can think, actually, how many trees have we got on the school site? Roughly how much carbon is locked away on our school site? This worksheet then takes you thinking about the students' carbon emissions, the UK average annual and the US average, to then think about how many trees will we need to plant, or particularly maybe which type of tree might be a good one to plant in order to sequester or lock away the carbon. So again, there's some kind of crude maths to try and answer the question, how many trees would you need to plant, how many poplar trees would you need to plant, or how many oak trees in order to sequester your carbon emissions for a year. And for students it may be something like 6 trees, something like that. And then the idea is to think about land area. So knowing the area of the UK, we can think, how many years would it take for us to plant trees before we cover the whole of the UK in trees, and we can't plant any more. So when we've done this, I think we've worked out roughly it would take about 6 years before we'd covered the whole of the UK in trees if we were going to be planting trees to sequester our annual carbon footprint. And what that then poses is actually planting trees is part of the solution, but it isn't the solution, because we would just run out of land. And I know students often then say, oh, we plant trees somewhere else. And you think, well, if each country did this, we would very quickly run out of space. One of the last activities then is thinking, well, if planting trees isn't the solution, what else could we do? And you get students thinking about some of the other ideas in terms of maybe changing where we get our energy from, thinking differently about travel, and that then sort of introduces some of the ideas that we're then going to come into in future lessons. And the last activity, though, is a bingo activity. So looking at some of the language, so this lesson introduces maybe some complex language, that you can write a list of maybe 9 words, get students to draw a grid, a 3x3 grid, and then you can have a go at playing a game of bingo by reading a definition or just saying some words which define or explain one of those words, and then the students have to cross them out. And then as soon as you get the first student with 3 across or 3 up, they've then got bingo.